Welcome to e-Padasala, PG students for computer science. In this lecture, we will be looking at 8051 microcontroller and its overview. So, when I am looking at this particular topic, we will be looking at the different manufacturers and different manufacturers of this kind of microcontrollers, and we will be looking at the overview of 8051 microcontroller, and we will be looking at the different functional units in the microcontroller. So, when I am looking at microcontrollers, we will have a different kind of controllers are available, 8-bit microcontroller, 16-bit, 32-bit. So, we will be having a variety of microcontrollers which are all available, and different manufacturers are manufacturing this kind of microcontrollers. So, when I am looking at the manufacturers, Intel is we know very well the Intel is very famous, as well as Motorola is also manufacturing microcontrollers. Zilog is also manufacturing, and Microchip is also manufacturing. Intel 8051 is very famous. The same way Zilog Z8 is famous, and Motorola's and Microchip PIC controller is very famous when I am looking at 8-bit microcontrollers. These people are manufacturing microprocessors also, but microcontrollers of 8-bit is also very famous with these manufacturers. So, when I am looking at 8051, now we will be targeting towards only 8-bit microcontroller, that too we will be restricting towards 8051. So, when I am looking at 8051 family, where the different manufacturers are coming into picture for manufacturing 8051 family microcontrollers. So, Intel is actually manufacturing 8051, this is their original architecture, and Atmel is also manufacturing 8051, and Philips is also manufacturing. AMD, we know they are very famous persons, they are manufacturing 8051, and Infineon, previously Siemens, will be calling it as Siemens. So, Siemens is also manufacturing 8051 family architecture, and Dallas Semiconductor is also manufacturing this kind of 8051 family microcontrollers. So, when I am looking at the 8051 architecture, the picture shows the 8051 architecture, where this 8051 microcontroller will have, as we discussed in the previous classes or lessons, we know very well this will be having this microcontrollers are having a CPU, will have memory, will have ports, as well as will have timers and interrupt. So, everything is inbuilt in a single chip, we will have all these things. So, if I wanted to build a particular application which requires only a less it is not requiring a very high end operation, by the same time a small product you wanted to develop, then this 8051 controller itself is more than sufficient to provide, because it has CPU, it has memory, it has interface, it has time, all the things are which available over there. So, now you just see that this is a CPU, whatever be the processor, whether it is a microprocessor or a microcontroller, will have a CPU. So, this CPU will be similar to your normal computer system CPU, that means a processor is there and will have on chip memory. So, this on chip memory is nothing but read only memory. So, read only memory in the sense all your program codes will be coded onto this particular RAM, and if I wanted to put data onto that, this can be put it in my RAM. So, these two are on chip. We have a on chip RAM, we have a on chip RAM also, and remember that we will be having IO ports. We have IO ports as well as serial ports. So, IO ports in the sense these are all parallel ports, we will have P0, P1, P2, P3. So, 4 ports are there, each will be 8 bits. So, now I have a serial port is nothing but we will be having a serial communication which will be established. See, some of the data we will read it from the input devices as 8-bit data. Sometimes you wanted to read data 1 bit after 1 bit, maybe the input device is giving you a serial data bit, then people will be going ahead with serial I will be receiving the serial data from the input devices 1 bit after 1 bit. So, that has been done through this particular serial port. So, sometimes I wanted to send a data where the output device requires only a serial bit, one bit after one bit serial communication, then from there this is providing a space to send the data one bit after through this particular output. This transmits that way. When I am looking at this kind of I/O ports where 4 ports are there, parallel data can be sent and parallel data can be received over there. That means, usually I have 4 ports, but remember that this P0 and P1 is used for address and data. That means, maybe I may not be in a position to write my code or my application is built up on these memories which may not support or which is not sufficient. By the time I can put an external memory also over there. So, if I am having an external memory, that particular memory is connected through these ports. So, the external memory can be addressed through P0, P1 and address bar, it is actually a multiplexed port. So, address and data is multiplexed together to send through these ports. So, maybe your data as I said, this is a 8051 is a 8-bit microcontroller. This is capable of handling 8-bit data. So, the data can be sent through any one of the port, but the address can be sent through either this or combined together. So, I can have 8 and 8. So, 16 2 power 16 is the major size of the memory this particular system will support externally, and data should be always 8-bit. So, the maximum 2 power 16 into 8 memory, external memory can be accommodated supported by this particular 8051 controller, where we will have a bus. So, you know very well, if I wanted to have access any of the things which is outside or inside, it has to be done through your data bus, as well as the whole system is controlled with the system bus and control bus. So, your data bus, control bus and all those things is accommodated by this bus control. And remember that these are the things which is always available with our normal PCs, but when I am looking at this controller, I have 2 timers. So, in the microcontroller itself we have 2 timers, timer 1 and timer 0, and we will have an oscillator. The CPU will have some clocks which will be given, as well as I can connect externally an oscillator and it will provide clock pulse to your CPU. So, this particular microcontroller is capable of accommodating timer, it is having timers as well as oscillators, and other than these things, the interrupt is very important. So, I have external interrupts as well as whatever be the interrupts I can provide it that can be given to my CPU, like external interrupts or timer interrupts or serial interrupts. So, so many things which is which can be handled by this 8051. So, if I wanted to build an application using this interrupts, this application can be effectively built up, and you can run that particular application in this particular 8051. So, this blue color is telling you about your buses. So, through which only your data is getting communicated to each other, and this will be controlled by this bus control. But anyway, the overall thing is controlled by your CPU. As we know, the CPU has your ALU as well as your processor and memory, all those things which will be available in your CPU as like your computers. So, this is the overall architecture of your 8051. So, now you just see that the overview of 8051, which tells you that this 8051 is a 8-bit processor. It will process at a time 8-bit data always, and if you want to process more than 8-bit, you have to write a code accordingly, so that it will process. It does not mean that it cannot handle more than 8 bits. And now 8051, what are all the features which is available with your 8051? One is I told you it has a RAM and a read only memory, but I did not tell you about what is the size. Now, this is the specification. So, 128 bytes of RAM will be available over there. So, random access memory is 128 bytes. So, I can read and write 128 data, 128 bytes of data, maybe I can use it with your 8051, and your on chip read only memory is 4K bytes. All your program codes will be written onto this 4K bytes, and we have two timers T1 and T2. Using that, I will be handling so many operations which will be confined to certain time, and only one serial port is available over there, through which I will be communicating input as well as output. And 4 IO ports, each 8 bits wide. 4 IO ports are there. It can be useful to connect any of the devices as input output devices, as well as I can connect external memory through these ports, and 6 interrupt sources are there. So, this interrupt sources will help us to build up applications on to this particular embedded 8051 controller in order to make embedded system. So, you actually before 8051 people made the Intel made 8031. This is a family, this is the earlier version of your 8051, where the read only memory is very less and it needs external read only memory, because 8031 is having memory very less. So, we will be connecting external memory, and 2 ports dedicated for addressing external read only memory, only 2 ports for IO operations, there is no 4 ports. So, by looking at this particular summary, you will be finding it, this is 8031 is the earlier version, where we will be having read only memory as 0. So, if I wanted to write a code over there, I will be writing it externally and it will be read, or I will be using a read random access memory, which will be of 128 bytes, and I have 2 timers and IO pins are 32 pins, that means 4 ports are there, serial port is 1 and interrupt sources is 6. So, when I am looking at, currently we will be looking at only 8051, this is this has been developed after 8031. So, in this 8051 we will be having a 4K memory, read only memory, where the code will be written, and 128 RAM bytes and 2 timers, 32 IO pins and 1 serial port and 6 interrupt sources. Later people went towards 8052. This is actually advanced version of your 8051, where this is also a 8-bit processor only, and the RAM is 8K. Now, the memory is enhanced to 8K, and your RAM read only memory data accessing is done through 256 bytes, and timers, not we will not have only 2 timers, we will be having 3 timers, and as usual 4 ports are there, 4 parallel ports are there and 1 serial port, but interrupt sources here is 8. So, it is actually an advanced version of your 8051. So, now when I am looking at 8051, as I said, many people are actually the Intel is base for 8051. So, after Intel, so many people tried in this 8051 microcontroller, and the same kind of 8051 family microcontrollers has been developed. So, one is very famous thing is Atmel 8051, where the program memory is a flash memory. There is no direct program memory is there, flash memory is used as your program memory, where the read only memory burner which will support the flash memory of this particular chip, and the separate eraser is not needed, because you will be using a EEPROM which will take care about reading and writing onto this data. And the next one is your DS89C4X0, which is from Dallas, where the flash is flash comes with the on chip loader. So, the loading a program onto the chip flash via your COM port, that means your serial through your serial port itself you will be in a position to load your data. And you have another one is your Philips 8051 microcontroller, where you will be having a analog to digital as well as digital to analog, DAC as well as your the data extension has been data can be converted, this has been provided by the system itself, and extended IO, and both on time program and flash memory also will be accommodated with your 8051 microcontroller of Philips manufacturer. So, now when I am looking at, maybe I am looking at only the Intel's 8051 microcontroller, where this particular one will be supporting the different clocks, one is 11.0592 another one is 12 and 16 megahertz. So, 2 or 3 clocks will be supported. One is internal clock is there, external clock is there, and an oscillator is connected to provide the clock also. So, as I said, 22 megahertz or 16 megahertz or 12 megahertz or 11.05 megahertz clock can be given to your 8051, but usually internally 12 megahertz clock is given, and because 12 megahertz clock is given, the processor instruction cycle time is 1 microsecond. So, one machine cycle requires 1 microsecond. So, what it means is one system command is executed in 1 microsecond, and it has an ALU which will process 8 bit, that is 8 bit ALU is there, and Harvard memory architecture. That means the external program memory as well as the data memory have separate address spaces from whatever be the size, and separate control signals. So, what it says is, if I wanted to move the data from your on chip memory, I can use move as opcode. When I am moving the data from external memory, then I will use move x or move c based on whether it is a code or your data. So, it is possible you can move data from external memory as well as you can move read data from your internal memory also. So, when I am looking at an internal data bus with 16 bit internal address bus, see the 8 bit internal data bus, and when I am looking at external data, external memory, I can go up to 16 bit. So, Harvard memory architecture is there, that only I told you 2 power 16 is the maximum memory I can accommodate, because 2 ports are supported for your address. And this architecture, whatever be the this 8051 architecture supports complex instruction set computer. That means CISC is the instruction set with which the system is supporting. As we know that it though it is looking at complex instruction set, the processor takes more time to process a single instruction, but pipelining is not that much supported by this kind of architecture. So, and other than the special features are, we have a special function register. The 8051 has its own register bank, where we will have 8 register. You will have 8 registers are there, each one is of 8 bit, and the special function registers is also available over there. So, the special function registers are SFRs or PSW, program status word, the process status word, and accumulator, B register, stack pointer, and registers for serial IOs, that means UART, timers, ports, and interrupt handler. So, when I am looking at normal 8051 register banks, which will be named R0 to R7, which will be handled by the programmers. You can handle it very easily through your assembly codes. And other than that, these are the special registers are there, which is made for a special purpose. It cannot be handled by the programmers or the users. So, this special function SFRs is a special function register. PSW is program status word. So, whenever the program, when the system is running a particular code, by the time what is the status of the processor, that means program status word, or I can call it as process status word. If I am running a code, by the time what is the way the process, what is the state with which the processor is existing, that can be identified with this particular 8 bit registers word. And as we know, accumulator is a major register which will be used by your ALU for processing, and the accumulator is the register which hold one of the source operand. And B is also a register, where maybe for division and all those things B register is used. Stack pointer is used for handling your stacks, and registers for serial IOs. So, serial communication is established. So, if I am looking at serial communication, I should read the data serially, but it has to be constructed into a 8 bit data, then only it will be sent for processing. So, for that particular purpose, we need a buffer where you will be having a UART. The buffer SBUF, you will be serial buffer is called SBUF. So, that will accommodate your serial data. Once you will be getting 8 bit data, then it will be made it into a single word and it will be sent for process. For that particular process, the serial IO serial buffer is used. Timers, ports, and interrupt handlers is handled, and all the status as well as masking or enabling those things can be handled by this special purpose registers. And some of the special bit manipulation instructions is also there. 16-bit program counter with usually maybe if I am reading it 16 your program from 16 2 power 16 as the memory size, then 16-bit address should be accommodated with your program counter. As we know, program counter is a register where the next instruction address will be hold. So, now the program counter holds the address of the next instruction, where if it has been read from outside, then 16-bit can be needed. So, because of that your program counter may have 16-bit counter, 16-bit address, and sometimes with if I am reading the code from internal memory itself, in the sense I need to have only a lesser size, that is more than sufficient. And we have a 8-bit stack pointer. So, all your stack value is placed internally only. So, we need to have only 8-bit address, because of that the stack pointer has only 8-bit. So, now if I am looking at the 8351 version, where on chip RAM 8751 version is having a EEPROM, 8951 version has on chip electrically erasable and programmable RAM and flash memory of 4 KB, which will be available. So, when you are going ahead with advanced versions of your embedded systems, will have an advanced version of memory is attached. Either I can have read only, I cannot write it. When I am looking at EEPROM, I can program it. If it is electrically erasable, programmable, then I can overwrite, all those things has been done. So, when the evaluation, when I am going high and high versions, where I will be providing much capable memory also to the system to handle its code also. And when several versions provide a higher capacity read only memory, additional program memory can be added externally up to 64K. So, I can add up to 64K in extended 8051 and unified address space versions 8051 EX and MX versions. This limit has been extended to 16 MB. Now, it has been it can be extended up to 16 MB. So, we have two external interrupt pins, interrupt 0 and interrupt 1. We have two external interrupts which will be supported by your 8051. One will be your INT 0 and another one is your INT 1. So, these two interrupts are external interrupts through which you can give interrupts, so that certain programs can be invoked, so that any application can be built through that particular interrupt. So, 4 ports of 8 bits each in single chip mode. See, here we have 4 ports P0 to P3, where each one will be supporting 8 bits, and we have 2 timers, timer 1 and timer 2. You can use it while you are coding for doing implementing certain applications. And sometimes you may have a input output devices which will be of serial nature. Then we have a programmable 3 full duplex UART modes for serial IO. The IO with each bit of word successive transmission on the data line for a time interval. The same may be programmable for half duplex also, either full duplex or half duplex. Both the things will be supported in your serial interface with this 8051. Depends on your applications, whatever be the input devices or output devices you wanted to support, it can be supported through this kind of 8051 controller. So, in some versions DMA controller is also accommodated, and in certain versions the pulse width modulator, then DAC and servo motors, all those things also will be accommodated in the system itself. So that the application which we need this kind of support can be implemented with this microcontroller version itself. So, in certain versions modem, your timer, analog to digital controller. So, this has been supported, and your Siemens machine which supports analog to digital converter with programmable reference voltage, and advanced versions support these features, and a version is selected as per the system requirement. So, you can select anything whichever is the application you need this kind of supports. So, when the limited I mean when I am looking at this kind of things, I know very well the 8051 will support many of the applications which we wanted to develop with a limited memory space, as well as the speed is also slightly reduced, but the cost will be very cheap. I can tell you this 8051 may cost around within 100 rupees. So, based on that, if I wanted to develop a simple application, it will support 8051. That means, simple application in the sense you wanted to generate as a small toy or a small controller or a sensor, or what you wanted to generate door closer or door sensor, or something which needs only a lesser processor support, and it does not require more what I can say is the fastest processor, but you need to have a processor as well as a controller to design an application which needs only a lesser lesser end, I can set lower end processor, then people always will support towards 8051. And with the 8051 microcontroller, we have something like all the timers, all the interrupts, as well as some of the advanced versions, as I told you, which will support the analog to digital conversion, as well as it supports modem and timers, external timers, and it supports something like different timers, as well as it supports different clock speeds from outside. So, I will be in a position, I will be given a hand to design different applications which will be in a position to generate, but with only a very less cost. So, for that usually people going ahead with toy like applications or something which is not needed to have a high precision, then people will go towards this kind of 8051 based applications. So, in this course we have gone through different manufacturers of microcontrollers like your Philips, Atmel, Zilog. Usually the Zilog will be Z80 is a famous microprocessor. Here they have generated Z8 as 8-bit microcontroller, and PIC controller is also there. So many manufacturers are generating very interesting as well as useful 8-bit microcontrollers, and we have gone through its specifications also, and we have gone through the overview of 8051 controller, and what is available over there is also we have gone through. And after that, what are all the functional units which are available in 8051 is discussed, and if I am having a 8051, what should be the limitations of that particular units, that also will be discussed. So, we have only 4 parallel ports and 1 serial port, and the memory is only 128 byte as well as 4K read only memory is there, but the thing is it is very cheap. So, based on that we should develop any of the applications which needs only a very less memory space, as well as the cost requirement is also less, and it is not high precision oriented, then it is very good to select 8051 microcontroller. So, now all these things what we covered in this lecture as reference is taken from 8051 microcontroller and embedded systems using assembly and C by Mohammad Ali Masri. Thank you.